In this video, we look at factorials and permutations. Those are probably new words for you, but we'll kind of go through the process and talk about what they mean and how to use them. So let's look at this example to start with. How many ways can we arrange 4 books on a shelf? So I've included a location here for each of the 4 books. 1, 2, 3, and 4. And we have 4 books, and we're going to place all of them on the shelf. So let's say this is slot number 1. We haven't placed any books on the shelf. You should think about how many choices do we have for slot number 1 when we go to put a book there. Well, there are 4 different possibilities for a book that we can put in slot number 1. Once we've put a book in that location, how many books are left? Well, we've placed 1 book. We had 4 to start with, so there must be 3 left, which means that we have 3 choices for slot number 2. Slot number 3, we have 1 fewer choice. There are only 2 choices left. And the last slot, once we get down here, we had 4 books to start. We've placed 3 of them. There's only 1 book left. Because we want to place all 4 books on the shelf, we had 4 choices for the first slot, and then 4 choices for the next slot, and so on. We're doing all of these, we're filling all of these slots. So this is a situation where we have a book in slot 1, and a book in slot 2, and a book in slot 3, and finally a book in slot 4. So then the total number of ways that we can arrange the books on the shelf, 4 times 3, which is 12, times 2, which is 24, times 1 is equal to 24. Now the trouble with doing it this way is I chose a number like 4 that was quite small, but if you were looking at 31 books and how to order 31 books on a shelf, that becomes a very tedious process. Luckily, we have some notation to help us with it, and that's what a factorial is all about. So we're going to look here at this factorial definition. Looks a little bit unwieldy at first. We use the exclamation mark to indicate a factorial. So this is factorial. That's how we say that. So n factorial. And it just means take the number n and multiply it by every integer less than n all the way down to 1. So we start with n and we multiply that by 1 less than n, 2 less than n, 3 less than n, 4 less than n, and so on until we get down to the number 1. So for example, 5 factorial is equal to 5 times 1 less than 5, which is 4, times 1 less than that, which is 3, times 1 less than that, which is 2, times 1 less than that, which is 1. We multiply that all out and we get an answer of 120. Now, one of the things that I should mention here is that by definition, 0 factorial is equal to 1, which may not be intuitive, but it's a rule and it helps everything work. There we go. So 0 factorial is equal to 1. Maybe let's try that again. Most of the calculators, most scientific calculators I should say, will have a factorial button on them. And you can find that factorial. It might look like this. Might be an n with a factorial. It might be an x with a factorial. It might just be an exclamation point. Or sometimes the factorial buttons are hidden under a probability menu, usually indicated by a PRB on a calculator. So if we find that button on our calculator and we type in 5 factorial, the calculator will spit back 120. So again, if we were doing a large number like 31, we wouldn't have to do 31 times 30 times 29 and so on. Our calculator could do that number for us. So that's what a factorial is. Really handy to save us a little bit of time. Let's move on now and look at permutations. So a permutation, by definition, is an arrangement of objects. You can take some of the objects or all of the objects in which order is important. And the key word here is order. So when we talk about permutations, we're always talking about the order being important. This will matter in a couple of days once we start looking at combinations. So basically a permutation, we write a permutation like this. The notation is here. So P stands for permutation. N is the number of objects that we have. So this is the number of objects. Maybe we should call it total number of objects. That might be a better So total number of objects. And then R is the number of objects being taken. So the number of objects taken. And we can write this, we can see permutations written several different ways. So this is another way that you may see a permutation written. It's a little bit harder to actually type this on a computer, you know, having to deal with subscripts and so on. So this is a way that we often see it, but they both mean the same thing. Let's have a look at some examples here about what we mean here. So in the example that we did before, we talked about 4 books on a shelf. So we actually ordered 4 books on a shelf, and we took all 4 books. So when we did that, that was a permutation of 4 objects where we took 4 things. And we came up with an answer for the number of ways to do that. If, for example, we decided we don't want 4 of those books, we don't want all 4 of those books, we only want 3 of them, we could actually write that as a permutation where we have 4 objects to choose from, and we want 3 of those objects. So now we're going to start talking about, well, what does it mean to have this kind of setup? So if we had 4 books to start with, and we only want 3 of them, we can go back to the same sort of model that we set up earlier. So we have 3 spots that we can put our books on our bookshelf, and we have 4 books to choose from. So if we have 4 books to choose from, you can think about, well, how many choices do we have for this first location on the bookshelf? Well, there were 4 books to start with, so we have 4 options here. There are 3 options left after we place the first book, and there are 2 options left after we place the second book. So if we're going to place 3 of the 4 books, this is the number of ways that we can do that, which happens to be 24 as well. Let's look at a slightly different example. Let's look at what happens if we want to place 5 of those books, because something maybe a little bit interesting starts to happen. So if we're looking for the number of ways to make an arrangement of 5 books, 3 books taken from 5. Let me just draw some lines here so we can get this sorted out. So there's our 1 spot, our 2 second spot, and our 3rd spot. In this case, we have 5 books that we start with. Once we place 1 book in this location, there are only 4 books left here. And once we place a book here, there are only 3 books left. So again, we're taking a book and placing them in each of the locations. So we have a book in location 1 and 2 and 3. 5 times 4 is 20. 20 times 3 gives us 60. So these are permutations that we're talking about, ordered arrangements of objects. And in this case, we've taken some objects. In the example we did before, we took all of the objects and ordered them. It's still a permutation. So this works. Now, if we were going to do 31 books and we wanted to take 25 of them, this becomes a very long process. So there are ways around that. Well, it turns out that the number of permutations can be found using an equation, and that equation looks like this. So the number of permutations where we're choosing r objects from n objects, so there are n in total. So again, don't forget that first number here is the total number of objects. The second is the number that we're choosing. That is equal to n factorial. We just talked about factorial and what that means. Divided by n minus r factorial. And I'll show you why this works so that you have some understanding of where this comes from. So let's look at this example right here. We'll use this as our example to work with. So if we're doing, I'll try to skip down a line here. If we're trying to find the number of ways that we can arrange 3 objects taken from 5, we already said that was 5 times 4 times 3. Well, you can see this is the start of 5 factorial. And in fact, if we want to continue, and I'll just change colors here so we can keep in mind that this isn't actually here. I mean, there is 5 factorial right there. And then we have to divide by something to get rid of this 2 times 1. So we need to divide by, it's a factorial, but it's 2 times 1. Well, this number down here is just 2 factorial. And you might wonder, where does the 2 factorial come from? Well, the 2 factorial comes from subtracting 5 and 3. And here's the equation right here, the n minus r. So remember, n was 5 in our case, r was 3, 5 minus 3 is equal to 2. So this is really the same as 5 factorial divided by 5 minus 3 factorial. So using the information that we were given in the question, we can evaluate this. And again, your calculator does have a button for permutations. It probably looks like this. There are different options. It may look like this, P bracket n comma r. It may look like this, a capital P with a subscript n on the left and a subscript of r on the right. Or it, again, might be hidden in a probability kind of menu. So those are the things that you're looking for. Again, find the button on your calculator. Try a permutation. So the way that the buttons work, I should mention, is for finding the number of permutations of 3 objects taken from 5. We, on most calculators, I believe, we would type in a 5, press this button, and then press our 3, and press the equals button, and we should get an answer of 60. So try it out on your calculator. Make sure you're comfortable with that. Again, the nice thing about the calculator is it saves us some time, and the nice thing about this equation is it saves us some time, especially when we're thinking about arranging 31 books on a shelf. Okay, so that's some work with permutations. It's probably worth looking at an example. So let's maybe flip to a new page here, and let's do an example. So let's say a choir. Here we go. We'll start. So here's an example. Oh, let me change my pen. So we'll say that a choir can sing 8 songs. They know how to sing 8 songs. Let's try that again. All right, so a choir can sing 8 songs. Might be faster to type this. How many ways can they sing or choose to sing 3 songs at a concert? So they know 8 songs in total. They've been asked to perform 3 of them. How many different arrangements of those 3 songs could they possibly have? So again, I'll do this 2 different ways just to show you what that looks like. I'm going to use this method over here. So we have 3 different locations, 3 different spots to fill. They're allowed to sing. So here's spot number 1. There we go. So spot number 1, spot number 2, and spot number 3. For the first song, song number 1, they have 8 possible songs that they can sing. Presumably, in a concert, you're not going to hear the same song over and over again. So let's assume that they're going to choose a different song for song number 2, which means that they only have 7 choices left because they've already used 1. When we get here, they've already used 2. There are 6 songs left. They're choosing a first song and a second song and a third song. So we can do the work here. 8 times 7 times 6. And we get an answer of 336. There are 336 different ways different orders that they can sing 3 songs from their 8. So that's a very common way to do this question. It works really well with small numbers. The trouble is, once the numbers get big, this becomes very cumbersome. So the idea here is that we can think about this as a permutation. They're essentially doing a permutation. We're doing a permutation where they have 8 songs to choose from, and they're singing 3 of them. They're going to choose 3 of them. So we can either use our calculators. I'm going to just show you how to do it without a calculator, or at least start without a calculator. So just a reminder from the formula earlier, a number of permutation is just n factorial. In this case, n is the number of objects, 8 factorial, divided by n minus r factorial. N is 8, r is 3. Let's put that in brackets here. So now we get 8 factorial over 5 factorial. And again, the nice thing about this is that 8 factorial is really just 8. Oh, let's try that again. Eight factorial is 8 times 7. Don't worry, I'm not going all the way down to 1. Times 6 times 5. Well, it keeps going all the way down to 1, but 5 times 4 times 3 times 1 is just 5 factorial. We now have a 5 factorial in both the numerator and the denominator. We can divide out those 5 factorials, and when we do that, we're just left with 8 times 7 times 6. And again, your calculator will do this as well, so you can plug in and check to make sure that you get the same answer with your calculator. So that's an introduction to factorials and permutations, just to give you a general sense of what's going on.